The universe is constantly in motion, and one of the most spectacular phenomena is the collisions and mergers of galaxies. From giant galaxies merging into one-to-neutron star collisions creating gravitational waves, each event leaves a significant mark on the universe's evolution. Recently, scientists have discovered a massive black hole in the Large Magellanic Cloud, LMC, on a collision course with our Milky Way galaxy. The collision is predicted to occur in billions of years, but its early detection has reshaped our understanding of galactic evolution, black hole growth, and the future of our home galaxy. Video, let. Please join us on this exploration. We know that a black hole is a celestial body with an extremely strong gravitational field, so strong that nothing can escape it, not even light. Finding a black hole has never been easy. It's like being invisible in the universe and emitting no light. Therefore, searching for a black hole is akin to looking for a black dot in an entirely black painting. They are invisible to conventional astronomical observatories. However, they are not without flaws. Black holes are voracious monsters with extremely strong gravitational fields. Leveraging this, scientists can detect them when they interact with their surroundings, such as when they actively suck in matter or exert gravitational influence on nearby objects. Recently, by cleverly observing hypervelocity stars in the Large Magellanic Cloud, scientists have uncovered a cosmic catastrophe unfolding in deep space. That is the supermassive black hole in the Large Magellanic Cloud heading straight towards our Milky Way galaxy. In the past, the galaxy has experienced cosmic impacts, collisions, and mergers to become the giant size it is today. But this is the first time scientists have predicted a merger with an approaching massive black hole. Using data from the European Space Agency's Gaia Observatory to map the precise motion of billions of stars in the universe, scientists discovered 9 stars in the Large Magellanic Cloud moving much faster than surrounding stars. This is very rare. Not only accelerating, they are likely to be ejected from the Large Magellanic Cloud, LMC. This implies there must be a massive invisible object with strong gravity affecting them. Upon deeper analysis, scientists identified it as the presence of a supermassive black hole with a mass about 600,000 times that of the Sun. This discovery is crucial because it confirms the existence of a supermassive black hole in the core of the Large Magellanic Cloud, something we had only suspected and couldn't confirm before. A mass 600,000 times that of the Sun is large, but compared to other black holes, it's only medium size, meaning it lies between high-mass black holes and supermassive black holes, which are millions to billions of times the Sun's mass. Discovering these intermediate black holes can help scientists understand how black holes grow. Do they actively accrete matter from stars to increase mass, or merge with other black holes in violent collisions? In this case, scientists predict that this black hole is likely to merge with the supermassive black hole Sagittarius A** at the center of the galaxy. Although this sounds apocalyptic, it won't pose an immediate danger. As we know, the Large Magellanic Cloud is a satellite galaxy of the Milky Way. It's currently 160,000 light-years away and moving towards the galaxy. According to simulations, in about 2 billion years, the Large Magellanic Cloud will collide with our Milky Way galaxy. When it happens, it will trigger a dramatic chain reaction of cosmic events. Gravitational disruption will warp the spiral arms of the galaxy, potentially creating new star-forming regions. The LMC's black hole will be pulled towards the center of the galaxy over millions of years. At the center of the galaxy exists a supermassive black hole named Sagittarius A*, with a mass about 4.3 million times that of the Sun. When two supermassive black holes approach each other, they begin orbiting each other, forming a binary black hole system. Over time, gravitational waves rippling through space-time, as predicted by Einstein, carry away energy, causing the black holes to spiral closer until they finally merge into one super black hole in a spectacular energy explosion. The merger of these two massive black holes could produce an enormous gravitational wave burst, spreading throughout the universe. The solar system is located in the inner part of the Orion Arm, about 27,000 light-years from the galactic center. Currently, our solar system is relatively safe from this galactic chaos. However, gravitational disturbances could push stars out of their usual orbits, possibly altering the structure of our local stellar neighborhood, and in extreme cases, it might even change the Sun's position in the galaxy. However, that doesn't mean it will wipe out life, as life on Earth would have long been extinct before the collision event. According to calculations, life on our planet can only exist for about another 1 billion years from now. After that, oxygen on Earth will deplete, and life forms requiring oxygen to breathe will be the first to perish, followed by other animal and plant species. The collision of the LMC black hole with the galaxy is expected to occur in about 2 billion years. By that time, our solar system will likely be a dead planetary system, with the aging Sun on its way to expanding into a red giant star. Galactic collisions and mergers are not rare in the universe, they are an inevitable rule. Our galaxy spans about 100,000 to 180,000 light-years in size. This size is the result of collisions and mergers over billions of years in the past. The collision between the black hole, the Large Magellanic Cloud, and the Milky Way will bring our galaxy a rare event. But unfortunately, we will never witness it firsthand. Scientists say the collision with the LMC is just a preview of an even more spectacular event. That is the collision and merger between the Andromeda Galaxy and the Milky Way. According to calculations, the merger between the Milky Way and Andromeda is predicted to occur in about 4.5 billion years. Now, let's look at the positions of the galaxies in this local group. The Milky Way, where we belong, is part of the local group of galaxies. This is a diagram of the relative positions of galaxies in the local group. The local group is a collection of various galaxies, including the Milky Way, the Andromeda Galaxy M31, the Large Magellanic Cloud, the Small Magellanic Cloud, etc. No one knows the exact number of galaxies in the local group, as some are obscured by the Milky Way. But at least 80 galaxies are known, most of which are dwarf galaxies, meaning small galaxies with star counts ranging from 1,000 to several billion stars. Estimates show that the local group has a diameter of about 3 mpc, equivalent to 10 million light-years. If you imagine skillfully, you'll see the local group has a shape like a dumbbell. The Milky Way and its satellite galaxies form one side, while Andromeda and its satellites form the other. The Andromeda Galaxy, also known as the Andromeda Nebula or M31, is the largest galaxy in the local group. It has a diameter of about 152,000 light-years and is 2.5 million light-years from Earth. That means light from Andromeda takes 2.5 million years to reach Earth. Our Milky Way is the second largest galaxy in the local group, with a diameter from 100,000 to 180,000 light-years. Most scientists believe that in about 4.5 billion years, the Milky Way and Andromeda will collide. Calculations show that Andromeda is rushing toward the Milky Way at a speed of about 110 kilometers per second, equivalent to 400,000 kilometers per hour. The collision between the two main galaxies will cause planets and stars to collide, creating a new elliptical galaxy. Scientists have excitedly given it a new name, Mildromeda, combining Milky Way and Andromeda. Although we cannot witness this historic moment, the discovery helps change our understanding of the universe. The event confirms that galaxy collisions contribute significantly to the development of black holes, as small black holes merge into larger ones. Through this discovery, tracking hypervelocity stars can become an important method for finding hidden black holes in the universe. Additionally, it gives us a glimpse into the future of the Milky Way. While we often think of galaxies as stable, this discovery reminds us that the universe is constantly changing. Our galaxy is not an isolated oasis, but will merge, evolve, and be shaped by cosmic forces over billions of years. See you again in future space explorations. Best regards, goodbye.